Today on the BV3D channel, let's make some filament with the Creality M1. I'm Brian, and you are watching BV3D. Hello 3D printing friends, and welcome back. Okay, so today we're looking at a prototype of the Creality M1 filament maker. Thanks to Creality for sending this over so we could check it out. This thing is pretty cool. It's like a filament production line scaled down to fit on a desk. Looking at it, it's kind of wide and tall, but it's not very deep. It's not super heavy, so it's easy to move around if you need to. As a prototype, it's got a lot of 3D printed parts in it, like the spooling mechanism and the ductwork. To use it, plastic pellets like PLA go in this hopper, get pushed through a 3-zone heater to melt, and then get extruded out here. When the doors open at the start of a production run, there's a bit of a melted plastic smell going on. The M1 has air filters, but the door has to be closed for them to be effective. The extruded filament is supported by these hooks, guiding it past an 8-zone fan array that cools it while it gets stretched out into 1.75mm filament, and then the M1 winds it onto a spool. When this thing is running, it's moving a lot of air for cooling. All those fans are kind of loud, but once the M1 is doing the spooling and that big glass door is closed, the sound level drops off. And at that point, the HEPA and activated carbon air filters in the M1 can do their thing to keep the odor levels down. The M1 monitors the filament's final diameter and automatically makes adjustments to keep it within about plus or minus 0.07 millimeters of 1.75 millimeters. Creality is still tweaking the onboard software, so they're expecting to get that precision more in the plus or minus 0.05 millimeter range. There are two main use cases for this machine. The first is making your own custom filament from virgin raw materials. And to help with that, Creality included a big bag of matte white pellets and some master batch colors. The second use case is making filament from recycled failed prints, purge poops, and scrap like priming lines and supports you've removed from finished prints. In order to do that second thing, Creality has a shredder, the R1, but that wasn't available when they sent over the M1, so we can't really explore the new filament from old benchies angle. But we can make filament from new pellets. And so what we're going to do is basically perform a series of experiments in filament making to see what's involved and find out how well it works. So for this first experiment, it's all about the general process. The basic concept is easy to understand. Pellets go in, filament comes out. But what happens in between those two? Well, we're going to find out. For this first batch of filament, I'm using 200 grams of PLA pellets straight from the big 3-kilogram bag. The M1 is already on, so into the hopper the pellets go. And I made sure to put the carrier thing at the start of the track. We'll use this in a second to get the filament down to the winding area. I preheated the extrusion system on the M1, and that took about 5 minutes to get up to temperature. Then I started the pre-extrusion process. That starts pushing filament out of the extruder and into the little carriage. After a moment or two, I felt like the filament was flowing okay, so I started moving the carriage along the track to route the filament over the hooks that keep it above the cooling fan ductwork. This needs to be done at a bit of a slow and steady pace. If it's done too fast, the filament could stretch too thin, and if it's done too slow, the filament could bunch up. The carriage has a cutter built into it, but if the filament is a little too soft, it may not cut it. That happened here, so I used flush cutters to cut the filament, and then I fed it into the opening for the winding system. With fresh filament streaming out of the winding area, the screen showed that it was coming out a bit thin, so I think I may have gone a bit fast with the carriage. Fortunately, the M1 automatically makes tiny adjustments to the extrusion speed and winding speed to get the filament diameter in the 1.75 millimeter range. After about 5 minutes of the M1 fine-tuning the extrusion speed, everything seemed to stabilize around the 1.75 millimeter diameter point, so I got the filament threaded onto the spool and the winding process went well. The M1 automatically guides the filament back and forth across the width of the spool to give a pretty even winding. I ended up getting a little over 130 grams of filament on the spool. I knew I wouldn't get the full 200 grams back out that I put into it. A lot of what didn't make it onto the spool was the pre-extrusion part, where the M1 was adjusting the flow to get the right filament diameter. And the other part of that is just what's left behind when the pellets are running out at the end of a run. So, good to know there's a bit of pellet overhead that needs to be factored into a production run. That's okay though, making filament is, at least partially, an art form, and this is a learning process. I'd say count on going through about 50 to 100 grams of pellets at the start of a run so the machine can do its thing. So with my freshly made filament, I decided to print something to see how it performed, and thus, this Benchy was born. It's a pretty perfect little Benchy, and so despite the low yield on my first batch, this was a success. As a side note, if I had that R1 shredder, all the filament that didn't make it onto the spool would be perfect for dropping into that to give it a second chance. This is experiment 2, which is trying to make filament with color, and for that, I'm using the master batch. These are super concentrated color pellet things that mix with the main pellets to tint the filament. I think I want to try blue. Creality says a 100:5 ratio by weight of pellets to master batch is recommended. So I have 200 grams of pellets and 10 grams of the blue master batch. And these need to be mixed really well in order to avoid some parts of the filament being more blue and some parts being less blue. This time, instead of the Creality spool, I'm using a different one, so I had to take some measurements of it and enter those into the M1. That way it knows how wide the spool is, and it can calculate how far to move the guide back and forth as it winds the filament onto the spool. I loaded the pellets into the hopper, started the preheating sequence, and then started the pre-extrusion sequence. I got it down into the winding mechanism so I could see the diameter of the filament on the screen. And when it was in about the right range, I started it spooling. So when this run was done, I had a nice spool of blue filament. I already printed a Benchy, so this time I went with this model, the Stonebound Dragon by designer Ernestus. It would appear I didn't mix the master batch into the pellets evenly enough because I've got some slight color variations. It still looks pretty cool. I am going to have to do better on mixing the master batch into the pellets though. Now, experiment number 3, a red, white, and blue color transition spool. I want to make some filament that prints in 3 colors, going from red to white to blue over the course of its length. Sort of like how they do rainbow filament. I'll make up a 100-gram batch of red and a 100-gram batch of blue. I'll also use 2 100-gram piles of the matte white pellets. My idea is this. Start with the plain white to give the M1 plenty of material to get the filament dialed in at 1.75 millimeters. Then, as the hopper is getting low on the plain white, I'll pour in the red batch and let that run. When that gets low, it'll be back to the white pellets, and then I'll finish up with the blue. The end result should be a transition spool that goes from red to white to blue. When I print with it, the blue, being the last color onto the spool, will be the first color onto the print. So from the bottom up, the print will be blue, white, and red, but that means from the top down it's red, white, and blue. That's the theory anyway. Let's see how this works in practice. So far, this is working pretty well. I let a lot of that first batch of white run through until the filament diameter was right. Then I started spooling it, and about that time the pellets were running low in the hopper. So in went the red mix, and a few minutes later, the filament coming out of the extruder started going pink and then red. The red went on for several minutes, and then when the hopper started running out of red, I put in the plain white pellets. Once the plain white started going through the extruder, I noticed something interesting. The filament color went pink, but it never quite got back to just being white. That red is very persistent. After several minutes, the hopper started running out of white pellets, so in went the blue ones. And once the blue started going through, the filament started going from pink toward purple before it finally got to the full blue color. It'll be interesting to see what this looks like when I print with it. And to test this filament out, I printed this Desk Trash Can V2 by designer Pixel to Plastic. It's got the full-on red at the top, then, where I wanted white, it transitions to pink. In that part, there's another darker line of red, so I'm guessing there was a particularly tenacious bit of red in the M1 that finally let go. And then it's into the blue with some lighter and some darker bands. The color banding is not entirely unexpected with these small 100-gram batches of color. What this experiment shows me is that trying to transition from a color to plain white without first running the extruder until it's empty is probably not something that's ever going to work. Now that I think about it, I don't believe I've ever seen a red, white, and blue transition filament before that switches cleanly to white. This is probably why. Regardless, I like the result, even if I didn't achieve my goal of red, white, and blue filament. So for experiment 4, I'm going to try making up a larger batch of filament with a custom color to see if I can get more even color distribution. Creality sent me the 3 primary master batch colors, red, yellow, and blue. From there, I can mix any 2 of those primary colors in equal proportions to get secondary colors. Red and yellow to get orange, yellow and blue to get green, and blue and red to get violet. Creality also sent black master batch, so I can darken any of these and make pretty much any color I want. I just need to use the right proportions of master batch colors to the main white pellets. So I'm going to use 600 grams of the plain pellets and try to get about 500 grams of usable filament from this run. As for the color, I don't have a lot of orange filament on hand, so I think I want to try making some. Using the 100:5 mixing rule, that's 5 grams of master batch for every 100 grams of pellets. With 600 grams of pellets, that would be 30 grams of master batch. Splitting that 30 grams evenly between yellow and red means I need 15 grams of yellow and 15 grams of red. So let's do that. I'll get these mixed together and then put them in the hopper on the M1 and start things running. Now, I will say this filament is coming out darker orange than I was expecting, so if I was to do it over again, the ratio might be more like 20 grams of yellow and 10 grams of red. Or maybe I'd keep the 50-50 ratio of red and orange, but just use less of it, like 10 grams of yellow and 10 grams of red, so the white filament lightens the color up. Okay, in all, I produced a bit over 500 grams of orange filament. So, what to print? I've already done a benchy and a dragon and a desktop trash can. After a quick search, I found this hoodie pen pot, or pencil cup as I generally call them. It's from designer Morganja. The pen holder turned out really well. It holds not a huge number of pens and pencils, but certainly enough for one desk. I've still got color variations going on, but I think that's just the nature of tiny filament runs. In this case, the gradient from lighter orange to a little darker orange really works with this model. So, what do I think about being able to make filament at home with the Creality M1? Frankly, I think it's kind of neat. I mean, sure, I have trouble getting the master batch color mixed super evenly with the pellets, which leads to very slight color inconsistencies. But then again, I've seen occasional color inconsistencies in commercially produced filament, so it's not just me. So yes, this particular M1 is a prototype. Yes, it might have a few rough edges. That said, it works. And I've kind of come to appreciate the filament manufacturing process a bit more after using it. I think there's a science to it, sure, but there's also an art to it. And experimenting with this has been both super fun and at the same time it's been a learning experience. For instance, I learned to add an extra 50 to 100 grams of pellets to the start of a run to give the M1 enough material that it can make its adjustments and get the filament diameter correct. And if you need to purge out the previous material from the M1, you might want to add a bit more to that. I also learned that making a tiny, nano-sized batch of filament isn't necessarily going to work out well. I feel like a minimum of about 200 grams is probably going to be the smallest single batch you'd want to make. Like I said at the beginning, there are 2 big use cases for this machine: making your own brand new filament and recycling failed prints, scrap, and printer poop back into usable filament. When it comes to making your own, I'm guessing you'll be able to buy pellets not only from Creality, but from others, along with the master batch colors. You could add other stuff to the pellets as well, like maybe glitter powder if you wanted to make a sparkly filament. And maybe, with a big enough batch of pellets mixed together, the color variations can be minimized. Custom filament could potentially be a unique selling point if you sell physical prints of models. You could sell things printed in filament that literally nobody else on Earth has. How long does it take to make filament with the M1? Well, it took me probably 45 minutes or so to make the 500 gram spool of orange PLA. Is that good? Well, without having used some other filament extruder that does it faster, I have nothing to compare it against, so I'm going to say, yeah, that's good. If I'd had the R1 shredder to play with too, I could be grinding up the purge poops from my multicolor printers, along with supports, and the filament the M1 extrudes while it's automatically adjusting itself to get the final output to the right diameter. And I have been saving all that stuff in the hope that I'll get to play with the R1 at some point. So that's the Creality M1 filament maker. It's a filament production line that fits on your desk, and it works. If you're interested, there are links down below. Thanks again to Creality for sending it over. Thank you for watching, and big thanks to everyone who supports the channel, whether with channel memberships or by using the links in the description. If you liked this episode, give it a thumbs up and maybe subscribe so you don't miss new ones. Well, 3D printing friends, that's about all the time we have for this one, and now that we're at the end, let's go print something cool with some filament we made ourselves.